Hello. This is my submission for my Coursera homework for the AI product management module. This is the analysis of the energy output of a combined cycle power plant. In terms of the modeling options that were available to me, I thought let's try the Google suite of tools, given the applicability of that in the marketplace at the moment. So I spun up an instance of Vertex AI, loaded up the data set, and attempted to begin using the standard default parameters for doing so, as you can see on the far right. So 80% training split with 10% validation and 10% testing, pretty straightforward. And an optimization objective of RMSE, which again, fairly straightforward. The idea was to then experiment with different parameters. Experiment with different experimental parameters to see if that makes a difference to our predictability, right? Unfortunately, after multiple attempts, I had to give up in the end, primarily because of setup issues, as far as I can tell. In my work as a tech consultant, I've run into these sorts of errors quite often where there's nothing wrong with the actual attempt at prediction or the actual data pipeline. There is some sort of um, setup error within the application. So I doubt you'll be able to see this on screen. There's a few access issues. Certain libraries weren't available. Certain folders seem to not be available. After looking at this, I thought, right, left. For the interest of time, I had to move on. I looked at other tooling, so some of the options here were Alteryx and RStudio as an example. But ultimately, these either involved cost or had a steeper learning curve than I'd like to invest in at this point in time. So as a result, I moved back into doing this in Excel and following the linear regression example, as it were. So, uh, given that the tooling within Excel is rather limited, went for a standard multiple regression model. As you can see, the parameters I selected on the top right and the output on the bottom right. Fairly straightforward, nothing particularly onerous or egregious there. So what we have is a multiple regression model where the R square accounted for 93% of the variance within the data set, which I believe is fairly good, which indicates that the model is fairly predictive in that sense. The p-values for each of the coefficients as well, so temperature, vacuum, pressure, humidity, were also very high, indicating that they are also quite indicates that this result is very unlikely due to a sampling error or any other error, such as not a random outcome, right? And we also had a fairly small standard error, which is an indication of precision, which I think is a good thing in this instance. Um, Now, uh, one thing to bear in mind is I've also did a linear plot between between the target variable and the independent variables here, and they all followed the trends that you'd expect to see within the model, right? Within the coefficients that is. So temperature, vacuum, and humidity all had negative regression coefficients, whilst pressure had a positive coefficient. What that means is when considered together, to increase energy generation, you would need to decrease temperature, vacuum, and humidity whilst increasing pressure. One thing of note was uh, when you take each of these predictors in isolation, they all act the same way except for humidity, which reverses its effect. So what this means is in order to increase energy output, humidity should be increased. But when you add in all the other variables, it inverts. So you'd have to reduce humidity in that case, right? Doing further research on this suggests that humidity in this case is very likely to be perhaps a proxy or has um, interaction effects which aren't controlled for in this particular data set. So could be a proxy variable or a confounder of some sort that's creating this view. But either way, obviously in an environment such as a power generation plant, it would be very difficult to isolate just humidity. But it's worth noting that it does seem to have this an unexpected effect that the coefficient uh, uh, that the regression coefficients would suggest otherwise, essentially. And that's it.